swiftly.
That won't get you high up in the search engines.
No. Let's see who's connected.
You go back down, please.
Yeah, go back.
Just make sure it's all working. So is everybody?
Yep.
Sorry, I didn't pick an easy URL. Right, everybody there?
Mm-hmm. Yep.
Really? Close? People already voted. How's that? Right.
I've tweeted it.
Super. Right. So, WebSockets and WordPress. Who's here ever heard of such a combination? Okay, up the back. Okay, let's start the first poll. Originally I planned a really fancy demo, but I still into Monday mornings. Okay.
Oh, nice.
Oh, there's a bug. I haven't cleared off the boats. But no problem. So, we'll just go through it and tally it up. Yes, people will be right and the no people will be wrong. So, back to WebSockets. So, quite a few people, I assume, hands up if you've seen WebSockets before in action. Okay, not very many. WebSockets are a bit like magic, realistically. Real-time communication with your browser. No need for a page refresh. They're a verified spec, so instead of HTTPS, they're WS, and they connect to a WebSocket environment. Now, there's multiple ways you can actually do it. Real-time communication, or give the impression of real-time communication. So, who's heard of long polling? Hands up. Okay. Who's heard of Node and Socket.io? Well, okay. Hipsters. Who's heard of the PHP solution? Okay, well, real men boys. So, now I've used Socket and I've used Ratchet. I haven't done long polling. The days of you having to use long polling due to browser support are kind of coming to a close now. It's a great solution, and it was back in the day when browser solutions, or browser support for WebSockets natively were pretty poor and they were terrible. But now we're kind of approaching a day when we don't need to do fallback solutions. So I've used Ratchet for this demo, and there's a few pros and cons to each solution. The biggest one is, for me, it's quite hard to install. So I have to custom compile PHP modules, documentation, or lack thereof. It makes it hard work, and examples are slow on the ground. But it's got some great ones, like, let's say I'm stronger with PHP than I am with JavaScript, and that's great. It allows me to deal with PHP directly, and just the JavaScript on the front end instead of having to do a server solution in Node using Socket.io. And WordPress is PHP. Why would you want to keep two separate stacks of technology? You have your WordPress stack, PHP, lab, additional solution, and you have a Node stack with Express maybe, or whichever serving technology you want to use. But that's great. You've got two separate stacks, you've got two layers to develop. I mean, who wouldn't want to do that? It keeps you busy forever. Who here is a PHP developer and JavaScript developer and can do both to equal standard? Who here never has enough time in the day? So why would you want to develop on two different stacks? Life's hard enough as it is. Why not make it a little bit easier for yourself? So I picked Ratchet. I use this in a live environment. Well, you've just seen it. See what the volts are doing now. Volts. So, cool. Yes is winning. We have got some prevention so people can't cheat, which is quite good, because it looks like a cheating lot. Sorry, come on. Okay, so, moving into traditional WordPress. Everybody recognises it, I'm sure everybody here recognises it. And it's just a custom post type. Magic on the underside, which I'll show you in a minute. For everybody else, it's just a standard WordPress interface. So you can change the title. As soon as you click that update, hooks go out, and you'll probably all notice that your solution's in theory now have a new title. No page refreshes, pretty much close to instantaneous to all connected clients. So, how does this magic happen? Because it looks it from the surface. I didn't have to pay, no one had to press refresh, and it's just updating all the stats. So let's see where. Cool. So this is how it works. We have WordPress, REST API, and then we run a daemon, PHP daemon, and that calls out to WordPress. And then you have your browser, which listens in the topics sent via the web connection. So, who here's got great in-depth knowledge of WebSockets and has used them in the production environment? Okay? Right. So, basically you send out data, a push comes from the server, WebSocket listens in, and then the data is reflected in the browser. Now, for a browser to know when it's been actioned or what's ever happening is when you connect to a WebSocket, a topic is presented. Okay, I'm going to say, I want post updates. And then every time post updates happens, that person or that web browser will listen in for that topic and eventually it will come through, and at that point you action your JavaScript and you make stuff move, for lack of a better description. So we're going to go over to the WordPress side of things now, this bit here with the REST API. And REST API is actually, okay, let's ask a question. Who's heard of the REST API? It's getting there. Cool. So the REST API is actually a great solution for WebSockets. Well, a solution overall. It allows us to standardize what we're sending. So you can do an internal REST API call and send that response via the WebSocket, which is great because if you're going to have fallbacks in WebSocket, i.e. WebSocket's not up and running, it's overloaded, it's not handling the connection right, you can do a fallback to the API. Because essentially the data is the same. There's no, I haven't got to do a diff, although I will do that, come to that later. It's all just the same. So it makes our lives a lot easier because we can just look into the same data and the same data is presented no matter which method we use. Because this method here, this website, when you refresh the page, the first initial state of poll is provided by the API. Now you can do that via a WebSocket. On their subscription, it's an event, which I'll be showing you later. You can say, okay, send the initial state. I didn't have time for that. Screw the time machine. That's my reason. It doesn't work. So when the poll comes up, you provide the initial state, everybody can go. So if I refresh this, you see, it's now providing me via the API with this, and then if I do any changes on the back end, that's provided by a WebSocket. Sorry, I'm not very descriptive with my titles. Take one.
At least they're unique though.
Yeah. So, there we have it. One solution, API, is dealt with in two senses, via the WebSocket and via its additional HTTPS call. Right. Sorry my slides are a bit lacking. I've done these quite late last night. WebSockets will chew through data because they're active all the time. When a person connects to your website and the WebSocket's present, that every time you send or broadcast a new update, that goes via the WebSocket. Now, Traditionally, how many people sit on a web page, click once, and then never again touch that site? Lots of people, unless the site's doing an auto every 60 seconds pulls up new data. WebSockets will chew through data like you would not believe. So, the best practice in this case is the diff. Again, with the API, what we can do is provide two states. One before update, one after update. Provide a diff, and then because it's the same object effectively, just only the difference, we can merge that in very easily on the front end of JavaScript. Cutting down what you're sending, because if you look at this demo, I'm sending a full API call, effectively, via WebSocket, which includes everything, stuff that hasn't even changed. Publish date hasn't changed. Okay, title changed, but effectively not much. 95% of it didn't change, and that's all useless data that's been sent via WebSocket. No matter if the browser's consuming it or not, it's still gone via WebSocket, it's still bound. Improvements. Okay, let's first dive into the code, how this all links together. So we have a standard post type. Sure everybody recognises it. Pretty standard, nothing special. We also declare the API fields in this one. So we've got some registered API fields, and these are all like poll results, poll metadata, options, a few things I didn't get a chance to implement unfortunately. All very standard stuff. With custom callbacks, nothing special. Now, the interesting stuff happens in this file. This is the manager for all the real-time actions. So you can see there I've hooked into save post, poll vote change, and a poll option change. Now, unfortunately I had grand plans for this demo, but scuppered due to backups issues. So I literally use 1 event a minute save post, or I treat everything as a save post, which sends the full object. Ideally, in a great world, every time a vote would change, I'd send the vote numbers. Every time a vote option would change, I'd send the vote option. I wouldn't send the full object. And that's what the multiple actions represent, a possibility of that. So, look here, update poll rule state. So, all the actions tie into this. So, with the current filter, it allows me to hook into different actions, use natively. A way you could go is using the API, because we're using the API to provide each action as a context, and then you can change the look of the API depending on what method you're using. That's another method. So we hit down there, we have the post ID, and we get poll state, which does an internal REST call. So using the get variable, you can see there, standard API URL. And that returns an array of the object. We then append the subscription to the response, which we were talking about earlier, topics, subscriptions, they're both the same. In this case, we're going to use the action, but I've just done a little mapping method. And at that point, we broadcast. So we head down here to the broadcast. So, as I was saying earlier, the PHP requires additional modules to be installed. They can be a bit tricky. So we want to introduce a check for that. We want to make sure this is a post type that's meant to be sent out via the WebSocket. And at that point, obviously, is real-time on, which I'll bring up later, because this is running in a command line. So you see there, new poll, new connection. Every time I get a new connection, it tells me. Every time I get a new poll, it tells me. This is not a great solution in a production environment. You should be using like hypervisor or some other solution to manage a PHP daemon for your WebSocket script. But so once we get down to here, now this, as you can see, we start up a new socket. Well, the socket's already been started by a command line, and what this does is it connects to that socket that's been started by a command line and sends the data across. In obviously pretty handy command send. So you can see there a JSON encoded response, and that goes out. And then I have a script handling it, which I'll show you now. the server. I'll show you the server now. Right, that is a non-blocking loop action for Ratchet underlying. So you can see there, we bind to the WebSocket and we push, we're using the pusher that's shown here to handle actions. So, on subscribe, when a WebSocket connects to your server, an unsubscribe event is made. So, there, this line here, description, that's how the server knows that every time it gets a save post, it's to send it out everybody that's subscribed with the save post. They're all stored here. And then on real-time event. So this is the in and this is the out, effectively. So when I request something to be sent via this line here, this is where it ends up inevitably. So the response comes in, yeah, as entry. I decode the JSON, make sure it's valid, add a subscription, make sure the description topic's there, and I broadcast to all the people that are subscribed for that event. And then we have it. That is how PHP WebSockets know who to send to and who to send what, effectively. So, and you see down here I've got a few other events. I haven't used them, unfortunately. The voting stuff is done by Ajax. I ran out of time to push it through the WebSocket, but it would be quite trivial. But for this demo, I've said nobody is allowed to push in. It's only one direction at the minute, which kind of defeats the point. Well, it doesn't, because this is the out that's normally the real time that you want. In's never been a problem. It's always Ajax. It's pretty. But you can obviously go via WebSocket. Back to the slides. So, improvements. Now I've said about diff already. When you're building one of these, you'll come across so many rabbit holes. It's when I first started playing around with this, I use these to do scoreboards, voting for a production environment. It's a different way of thinking when you come to real-time communication. It's not just click a refresh, it goes one way, it fetches the data and that's it. What you do on anybody's browser can have repercussions across all your connections. For instance, in another demo, when I first started playing around with these, at this point here, when a subscribed person connects, I would just start out using it. They want an initial state of the object, wherever that may be. So at this point, I'd broadcast a solution to them, I thought. But actually, it turned out when anybody new connected to the WebSocket, it would rebroadcast the object to everybody that subscribed to that topic. So you quickly, your numbers that grow exponentially, because as soon as another person subscribes, boom, everybody gets broadcast. Another person, boom, everybody gets broadcast. It's not just that person. And this is a problem. The fun part would be, effectively, we're so used to communication being one way. When you start doing WebSockets, communications can go unexpectedly. Now, improvements, what else could I do? You could use, well, accepting votes by the WebSocket would be the obvious one. Log in the connection ID so you can do, originally I planned to do competitions. It's not a stretch to get all the connections that have voted for a particular vote and then pick somebody at random, have their phone scream at them or shout or whatever. You could pick that person out and they'd win a prize. It really is, once you start doing these type of things, it really is quite fun. You can really push it in crazy ways. So go back to the slides. So as I said before, I use this in the production environment for scoreboards. I use it for polling. A bit less complicated than what I showed, actually the same what I showed you earlier. Scoreboards are great for this. So as results come in for a particular match, the results are pushed out by the WebSocket to a scoreboard, and this allows people to see the results in real time. You think of who here watches the football on Saturday? Okay, it's probably not the best crowd. But you think of that screen technology that they have on an overlay on the football match, and they have all the matches being piped in via real time. You don't really see that in web technologies, but it's capable of doing it. With WebSocket, you could set up an overlay, and you could pipe in real-time match feeds. You could pipe in who's just lost, who's just won. It's just imagination with WebSockets. So scoreboards, polls. You can do, for instance, who was here last time? Was it last time we had that collaboration software? WordPress? Collaboration, they would probably use WebSockets because it all happens in real time and you share that data. So it really is a games, another one. We've seen who's here seen a JavaScript game? Okay. Well, JavaScript games probably use WebSockets. That's how it all works. Oh, we have another one of those. So, questions? Cool? No.
When do you think it's worth switching to WebSockets instead of just doing some really crude Ajax polling yourself?
It depends if you get the client to pay for it.
Yeah.
If you're having lots of real-time results, then you should probably use a WebSocket solution instead of just hitting the page every X amount of seconds, because it will save you bandwidth. You know, if you're sending diffs and there's a smaller overhead for a WebSocket connection than there is HTTP request, you establish your WebSocket connection once, and all the data just streams out. You haven't got to re-establish that connection. There's no overhead. Whereas with a traditional Ajax, you'd be pounding the server every 60 seconds, and that's yes, it's not a lot. Set up a HTTP request, send it back, accepting it. But that's more work for your server. So if you're dealing with large numbers and they all want real-time results, you'd probably save yourself server resources using a WebSocket because of the lower overhead. Especially if you go back to what I was saying earlier about using a diff, only send the difference in data. A person refreshes the browser, you send the initial state, and then you send the diff every time a change has happened. Who here has heard of Meteor.js? Cool. Meteor.js is a JavaScript library that works in real time. Now, they do diffs. It's all built into the core of it, effectively. You do an action, the action goes back to the server, but the browser assumes the action took place and then the server confirms, and then it does a diff and then works out if it did or not. And that allows you a very snappy interface with Meteor doing real-time applications. Now, I forgot where I was going with this. It was a good... Okay, we'll move on. Next question.
Question just really, is there sort of a risk from the amount of bandwidth or data that might get used if you're maybe not as experienced as yourself there doing it?
Yeah.
Is there any sort of bandwidth like you might suddenly feel like maxing out the server at your house or something like that? You can just raise the bottom of the thing. And is there also any sort of security risk as well? Is there sort of two-way side of it?
So it's standard security really. So one, you cut down the diff. So if you're doing the diff approach, the first time they connect, they get the initial object, and then any changes that happen with that object at the server side, a diff is sent to that connection. That's actually less bandwidth. If you just hammer home a full object every time, it's going to be about the same, maybe more. So it may, if you put the time into it properly, like if you're doing WebSockets first time, you've got to be careful in the production environment. I mean, we've all had hobby projects because we don't want to do a production environment straight off the bat because it tends to have unforeseen consequences. So it'll be do a hobby project, play around with it, and then once you've got to that stage and you're sending diffs, you actually find the server resources will probably be lower. As for security, it's pretty much all standard as you would with an Ajax call. There's nothing to say I couldn't authenticate at the back end with users if they were to post via a WebSocket. The data is the same. I can get a user ID and authenticate that way. It's very similar to cross-WordPress. As long as you put the precautions in place, yeah, it's fine. There is plenty of solutions for security, so you can't have somebody load a bot, connect to your WebSocket, and then just programmatically hammer your WebSocket. You can't set it so it won't only bind to a certain IP and from a certain. And you can also use JavaScript web tokens to help security.
What's the browser compatibility like?
Same as any WebSocket, which is a look. Pretty good, apart from obviously shocker. But there is JavaScript fallbacks, not JavaScript fallback, Flash fallback. A common WebSocket fallback technology is JavaScript. Sorry, Flash. Flash has actually done real-time communication before JavaScript. But then if you take the approach of using the API method, so you basically standardize the output, whether it comes via a traditional HTTP call or WebSocket call, there's nothing in your JavaScript you can say, is WebSocket available? Yes. Okay, traditional connection for WebSockets. If it's not available, then just hit a 60-second repeater on the API. It's not ideal, but it's possible. And that will give you the exact same look effectively.
How's SSL done with this sort of secure WebSockets? Is it?
I think it's instead of WS, it's WSS.
Okay, so
I haven't had much experience with these with the SSL.
so it's being used just like HTTPS.
Anyone else? Oh, sorry.
What's better than time machine?
Fucking time machine. I've used iDrive, that's backing up now, every night. Yeah, remember to back up, folks. Don't use iDrive, don't use time machine.
Do you have any more questions, sir?
Just ask, you said it was difficult to install the PHP site. Do you see that it's going to become easier?
No, this is not something you do on a shared host. It requires a VPS because you need to compile a ZMQ. More hardcore PHP people. It's it's a whole other topic. But yes, you have to run some command lines, you have to compile, and you have to change your PHP. You need to load in the additional extension, and you also have to do some composer work as well to get the requirements for React or Ratchet.
Correct. But so it's probably worth reading around Ratchet.
Yeah. Yeah, it's got. I've put the slides, so it's I think socketme.io. Socket 2, right? So that's built on some other PHP technologies, as always, built on back giants. And that's got documentation. Yeah, it's not the best documentation in the world. It'll get you up and running and something to play around with, and then go from there.
We've got time for one more question.
The code that you've written, is it open source? Can we read for it?
Yeah.
Or will it be?
I will tidy it up because I wrote this yesterday. I installed the environment yesterday and wrote the PHP and wrote the JavaScript on the way here and in the last 2 lectures and deployed it back. So once I tidy it up, I will push that to the management.
Excellent, thank you very much.